Hello there. So this is question 1. You're told to just solve the given differential equations just using this method here, the method of undetermined coefficients. Now that's the method we're going to use. So let me start by solving the first one. The first one, we're given that 4y double prime minus 4y prime minus 3y equals the cosine of 2x. Now to solve this, we know that the general solution should be of the form y equals yc plus yp. So where yc is the complementary function and yp is the particular solution. So to start with, I'm going to find yc, yc, the complementary function. So to find yc, I have to solve the homogeneous the associated homogeneous equation of this non-homogeneous differential equation, which is going to be 4y prime prime minus 4y prime minus 3y equals 0. Now to solve this, the first thing you want to find is the auxiliary equation. The auxiliary equation is 4m squared. So in place of y, you replace it with m, and then you have double prime. So that's m squared minus 6m minus 3 equals 0. Now when you solve this, what we would have is m1 equals minus half, and m2 as the second root equals 3 all over 2. So since these two are distinct, so that implies that our yc is going to be of the form c1 e to the power negative 1/2 x plus c2 e to the power 3 all over 2x. So this is our yc. So the next is we want to find yp. To find yp. Now, how then do we find yp? To find yp using the method of undetermined coefficients, actually we are going through the superposition approach, is we need an assumed form for the particular solution. Now the assumed form you're going to choose depends on the right hand side of the differential equation, and based on the ones we know, like we've known, the yp we're going to choose, so we'll say let yp be equal to a cosine of 2x plus b sine of 2x. So that's the yp you want to choose. Now before you begin to solve, you need to check that your yp, the terms in your yp, they have no twin in the terms in the complementary function. Now comparing the two of them, you'll observe that there is no twin. So we can continue. So I have my yp, so I need to find yp prime and yp prime prime, because we are assuming this is a particular solution. So for it to be a particular solution, it implies it must satisfy the differential equation. So I have to test that it satisfies the differential equation. So to test that, since I already know yp, I have to find yp prime and yp prime prime. So I'm going to find yp prime, so which is a cosine. When we differentiate this, you're going to have minus 2a sine of 2x, and when we differentiate this, we have 2b cosine of 2x. So we find the second derivative of yp, which is minus 4a cosine of 2x minus 4b sine of 2x. So the next is we want to do is we want to substitute all these values here into the differential equation here. So that's going to be 4 times yp prime prime, as minus 4a cosine of 2x minus 4b sine of 2x, then minus 4 as minus 4 times y prime. So that is y prime is minus 2a sine of 2x, then plus this should be minus 4a sine of 2x. So I'm using this here. So minus 2a sine of 2x plus 2b cosine of 2x. So that is what I have for my 4y prime. So it's remaining minus 3y. So that's minus 3 times y. This is my y here. So that's going to be a cosine of 2x plus b sine of 2x. Now all this should be equal to the right hand side for it to be a particular solution. So this must be true if we are assuming that yp is actually a particular solution of a non-homogeneous differential equation. So the next thing I want to do is I want to simplify the left hand side. So on simplifying this left hand side, so what I'm going to have is we're going to have as for this side you have minus into 19a, as after you have done the simplification, 19a plus 8b into the cosine of 2x, and the next one is plus, I think it should be 8a minus 19b. That's 8a minus 19b. 8a minus 19b times sine of 2x. Now all this equals 1 cosine of 2x. 1 cosine of 2x. So you can see that since there is it's as good as if there is 1 here. Since there is nothing here, it's just 1 times cosine of 2x, which is still the same thing as cosine of 2x. And then since we do not have any sine of 2x term there, it implies that the coefficient of sine of 2x in the right hand side is going to be 0. That's what it means. So plus 0 times sine of 2x. So our aim is to compare coefficients. So when we compare coefficients, now comparing coefficients, So when we compare coefficients, you observe that minus 19a plus 8b must equal 1. Why? Because the coefficient of cosine of 2x here is 1, and the coefficient here is this. So that implies that minus 19a plus 8b equals 1, and then 8a minus 19b equals 0. So we want to solve this. When you solve the two differential equations, the two simultaneous equations, what we have for our a is minus 19 over 425, and our b is going to be minus 8 all over 425. So now we have our yc, which is what we have up here, and we also have our yp, which I'm going to write as, so since my a is minus 19 all over 425 and cosine of 2x, plus our b, which is minus 8 all over 425 times sine of 2x. So, and I know my general solution should be y equals yc plus yp. So my yc, which is up here, is going to be c1 e to the power negative half x plus c2 e to the power 3 all over 2x, then plus my yp, which is what I have here, and that is I could just clear this off as minus 19 all over 425 cosine of 2x, then minus 8 all over 425 sine of 2x. Now this is your general solution to the non-homogeneous differential equation that we are given. That's for part A.